Good evening. Hello, everyone. I'll just start in a minute or two.
Good evening, ma'am.
Good evening. Okay, welcome back. Those who had also joined my earlier class, and to all the new ones, welcome to the second interactive session about wood and bamboo from the course Building Materials and Composites. I'll just quickly go through what we generally do for the new ones. So basically, it's a doubt clearing and interactive session which happens every Tuesday from 6 p.m. to 7 p.m. And how do we interact in this particular class? So, if, first half of this class is basically all about me putting up some questions and answering them. These questions are based on the graded assignments that you get, and apart from that, you all can also ask me questions. If you all have any question, ask me in between. Raise your hand, or you can put it on the chat box so that I can see and I can answer. And how else do we clarify the doubts? Those who all are, most of you, I guess, all are aware about the discussion forum. So there you post the questions, and you can also, get your clarifications through mail. And another thing is that if you check that particular, there's this one particular box or a particular tab has been added regarding the interactive session in the NPTEL, the website that you open whenever you open the website for accessing the different courses. So you'll get there also. So in case you miss any one of this particular interactive session, you can always refer back to those PPTs and to the videos also. You can have access to the PPT. Some of you were asking in the discussion forum regarding the access to PPT. So you'll get there only. And apart from that, so how will it help us? Obviously, it's for the it's since it's based on. Good evening, Harsha. Since it's based on the assignments, graded assignments, so of course it will be helpful there. And finally, when you are giving your final exam test that you will be giving, so it will be helpful for that part also. So let's now slowly move to what we have seen in this particular week two of the course building materials and composites. So if you remember, lecture 6 talked about a basic introduction to wood, then how wood is procured, what are its properties, its classification, all these things are there. So in lecture 8 we have seen that the defects of wood and wood joinery are being discussed in details. And then lecture 9 is about engineered wood. So apart from the natural wood, of course, what we will go to engineered wood, we'll talk about it. But yes, this lecture 9 is about engineered wood, and lecture 10 was about bamboo. So this is another material. Uh, and we will see in this particular interactive session, it's all about more into the maybe you can say more into the application part, also more into the things that couldn't be maybe discussed deeply in the course, but yes, the questions are coming from those part. So this is all about this particular interactive session. So today I will mostly like last week we had theoretical question and a numerical question. So this week no numerical questions. It's all our theoretical questions, primarily theoretical, and some of the pictorial questions are also there. Okay. So having said that, having given you all an outline of today's class, let's move to our first question, that which says that arrange the following according to the section of a tree trunk from inside to outside: uh, bast, cambium, sapwood, pith. Since, as I said, that today's entire discussion will be based on wood and bamboo, so let's move slowly towards the entire thing. Okay, so I would expect you all to answer. If you can't answer, it's not a problem, but yes, you can always try giving the answers. Any answer from you all? Okay, I might give you a small hint regarding this particular question, so that will be easier, I guess. Just a second. Yes, now I hope you all can see the tree trunk structure. So now is it? Oh, sorry, I'll just check the. Yeah. Okay, no one with the answer. I'll just see what do we have. We have to find the sections from inside to outside, right? So just a second. Okay, so if you look into the this particular answer, you can see that I'll just use my pen. Just a second. Just give me. I see there's some trouble. I don't know why the pen is not coming. Okay, anyway, so let's see into this. Then we will. So if you look into this particular tree trunk, you will see that the inside, the most in, if you look over here, so the most inside part is basically the it's the pith. Okay, so pith is the first thing that grows, and then surrounding it we have heartwood, we have the sapwood layer, and then the other things. Okay, so if we look into our particular this question, so you can see that the innermost layer will be pith, and then we have sapwood, that is R, and then we have cambium. Cambium is quite at the you can see it's at the outer layer, and then we have the absolute outside layer is known as the bust. So our sequence will be SRQP. Okay. Now, what is this pith? So, as I said, that it is the oldest part of any exogenous tree. So, the cross section that we saw was that of an exogenous tree. Then the heartwood. What is the heartwood? Heartwood is basically the portion which is surrounding the pith. Okay, and it is strong. It is dark in color, and it is the dead part of the wood. So this particular portion is very useful for the engineering purpose. What is engineering purpose? What is engineering wood? So that also we will see. But yes, then we have the sapwood. In this question we had sapwood, so it basically it's the layer just next to the heartwood. Okay, and it denotes the recent growth. It takes active part in the growth of trees by permitting sap to move in the upward direction. Okay, then we have the cambium layer, which was also there in this particular question. So it's basically a thin layer, okay, among the sapwood and the bark. So this particular sap is not yet converted, it has the sap, so that is why it is known as the sapwood. The moisture or the in the inner thing fluid about the tree, So that is present in this particular this particular layer, which is known as the cambium layer. And then the inner bark, even bark is having the inner bark and then the outer bark. And the medullary rays are basically the thin radial fibers which are extending from the pith, so from the inside to the outside. So that is the, so those are the medullary rays. Okay, so they hold together the annual rings. So this is the basic structure of the tree trunk, and I hope the answer is Nagma said SRQT. Absolutely right, Nagma. Okay, so let's move to our. Okay, before we move to our next question, this is one particular interesting, image I got, which basically shows that how we can cut, how we can cut the sections of a particular tree, or how we can cut, and if we cut it just from the top, we just slice it. So that's the cross section or the transverse sections. Why this is important? Because if you find in your particular course, you will see that there's this particular thing called sawing. I think this particular image will somewhat help you to understand or visualize how the different types of sawing, ordinary sawing and then quarter sawing, radial sawing, all those things, or the tangential sawing, all those things have happened. Okay, so if we just slice it, then it's the from the top surface, so it's the cross section or the transverse section. Okay, and if we just slice longitudinally, so it gives you the tangential section. And then if you try to cut it from the center to the outside part, so that gives you radial sections. And this particular thing I wanted to show in this from this image. And as you can see, also see that the different these layers are again marked over here, but this is just a three-dimensional figure as well. Okay, so let's move to our next question. So you have to identify the exogenous and endogenous trees. Yeah,
Let be
image
indigenous,
B is
let be
yeah.
indigenous.
Uh, uh, to buy a VFs, I guess there's some issue with your microphone. You can just type it down, because I don't know. I'm not getting enough of the audio. Yes, Harsha says A is endogenous. It will be E. Okay, not Indo. Yeah, Nagma says A is endogenous, and the second one is exogenous tree, which is mahogany. So first endogenous is the palm tree, and exogenous is the mahogany tree. Okay, okay. Just give me one particular. Just a second. I'll just take. Just give me 1 second. I'll just try to present it in in a different way, so that it's I am not being able to use the pen. Just give me. I'm not really sure why the pen is not working today, but just a second. Yeah, now this is working, so I'll just use it. Yeah. Let me just get back to exogenous. Sorry for the interruption. There was this particular technical thing happening. So yes, image A was endogenous tree, and image B, as you can see, it's the exogenous tree. Now let's talk about what's this exogenous and endogenous is all about. So I think from these two particular images, you all can differentiate what's exogenous and endogenous. But if we talk technically about exogenous and endogenous, so exogenous trees basically, they are the most maximum majority of the trees that we see here and there are mostly exogenous tree. Why they're exogenous tree? Because they grow by addition of new wood inwards. New wood, it grows inwards. So how, basically, as I said, that this one was the the old or this the pith, the first wood that develops, and then surrounding it, it keeps on adding like this. So that is why the screen is not shared. Okay, just a second. Thank you for. The screen was shared or not shared? Shared. See, just a second. I guess it was shared only. Just a second. Just a second. Yeah, now you all can see. Those who all can't see my screen, just pin my this particular screen which is showing the particular thing. Okay, I hope. Yeah, thanks Anjali for telling. Yeah, so that's what exogenous trees are all about. How this particular this layers are adding, that makes the difference about exogenous and endogenous tree. Now coming to the endogenous tree. So endogenous tree, if you look into this particular cross section, you see it's hollow, right? So that means that the layers are not added in this way. So it's something very different. So for endogenous tree, what happens? They grow by addition of new, materials inwards. So if you transversely, if you look into this particular transverse section, you'll now find that the endogenous trees have annual rings in their vertical direction. So that is how we basically, this differentiate between the exogenous and the endogenous tree. Now, why am I talking so much about this exogenous and endogenous trees? Because you all need to understand that not every kind of tree can be, used for, this particular engineering wood, or if you can just take each and every wood and just use it for building something. Okay, so each and every type of wood has got their own specific kind of usage. So that is the basic differentiation between these two types of trees, and that is how we will see the differences. So now, primarily the first half, we will all talk about the exogenous trees, its materials, how we are going to preserve it, and everything about it. Okay, so now let's move toward. I hope exogenous and endogenous tree, the things about it is clear to you all now. And now we will move to our next question. Okay. Okay, so I hope you all can see question 3. Thanks Anjali. um, Okay, so what does it say? It says that you have to select the correct option, where P is stating something. What is P saying? P is saying that softwoods are strong for direct pull and weak for resisting thrust or shear, whereas hardwoods are Q. In fact, the statement Q says hardwoods are strong for resisting tension, compression, and shear. So is P correct or wrong? And even the next statement Q, is Q correct or wrong? Okay, before you all, Sumit Sumit, Anjali, everybody says okay. Answer. Let's see what's the answer. Absolutely correct. To all those who have, yeah, all of you all have said C only. So it's true that softwoods are strong for direct pull and weak for resisting thrust or shear, and hardwoods are strong in all, it's tension, compression, and shear. So can anyone say that from where do we get softwoods? Like which type of trees, or which type of, yeah, whether it's deciduous trees or coniferous trees, from where do we get softwood and hardwood? Any idea? It was discussed in the course itself, but yes, if you all can remember, it will be once again a bonus. Anybody remember? Deciduous trees, yeah, softwood are from what? Deciduous or soft? Yeah, Dagba says softwood are from yeah, yeah, right, Smith. So basically, we get softwood from the coniferous trees, and the hardwood we get it from the softwood, coniferous trees like pine and the trees that we see in the mountains, and the this particular hardwood we get it from the deciduous trees, for example cedar, maple, mahogany, all this. Okay. Okay, so let's check the next one. So identify, so next question number 4 says identify the correct sequence of stages of timber. Okay, so what are the stages that I have talked about? So one, felling of trees, which is basically cutting the tree. Okay, and then cutting and sawing the timber or the wood for for suitable use. That there is another one. Next, seasoning, and then there's preservation. So which is okay. Everybody says option B. Yes, absolutely correct. If you all like, it's good to see that you all are following the classes, and you're understanding the minute, details about it. So first, the trees are cut, that is felling of trees, and then they are first seasoned. Okay, so the log of woods, they are first seasoned, and then they are cut for suitable, into suitable sizes. We have seen the different types of sawing, so they are cut into those suitable pieces, and they are also preserved. So also, if you remember, for preservation, there are different methods of preservation as well. Just as we have seen that there are different methods of cutting and sawing, there's also different methods of seasoning also. We'll discuss about the seasoning part of it. And apart from that, preservation also, we can preserve it with different means. For example, we can use arsenic, copper, this solution. We can use coal tar, we can use creosote oil. Okay, so all these things are commonly used for preserving the timber. Okay, so that brings to our next question, which is once again quite a easy one. You have to identify the type of timber seasoning. Yes, Anjali, it's the aluminium copper. It's the particular solution which is, you know, sprayed on top of, or rather, given. Rohit says, yeah, it's soaking, but there's this particular name of this seasoning. Anjali says water seasoning. Yes, anybody with any more answer? Okay, with no answer, but yes, Anjali was correct. Yeah, right, Rashmi. So it's the water seasoning of timber. So as I say, if you all remember, once again the course, you'll see that seasoning can be of again two types. Primarily natural seasoning, and the second one is the artificial seasoning. So when it comes to natural seasoning, it can be either by air, that can be just by air drying. It can be, even that is also one type of seasoning. And the other also, which is considered under this natural type of seasoning, is the water seasoning, where log of woods, they are just thrown into water, or rather placed in the water. And then what happens after, since this particular timber, this log of woods, they are basically immersed in the water, this helps in the removal of the sap that is present within the wood. Okay, so it generally takes about 2 to 4 weeks, and after that, then again, it's the drying time also is required. So what happens for this natural method of seasoning is that it generally takes a lot of time. So for water seasoning, it can be, it can, this entire thing getting immersed in water and then drying up. So this entire process can take up to 2 months of time. And then if we have even the dry kind of the wind air seasoning also, even if we take up that type of seasoning also, it can take up to 6 to 12 months for the particular wood to properly season. So these are quite time consuming things, and that is why we often opt for artificial seasoning as well. So let us see if you all can recognize the next type of seasoning. Okay, Rashmi, Harsha, all of you are telling clean seasoning. Okay, anything? I just hope I had clean seasoning photo, but this is not clean seasoning. This is Sumit says probably steam seasoning. Yes, sometimes it looks like steam seasoning, but also actually this is the chemical seasoning. Okay, where in chemical seasoning, what happens? So basically, a salt solution is prepared, and in that particular salt solution, this timber are basically absorbed, and then it's processed, and the particular timber, it the sap basically reduces. So why do we season? The basic motive of seasoning is to remove the sap content inside it, or the different the moisture inside it, since we know that it's a organic material. So that is the basic motive regarding this entire concept of seasoning. Now, there are other types of seasoning as well, as you all are saying. For example, clean seasoning. So, in clean seasoning, what happens? I just try to show it over here before I go to the advantages of timber seasoning. So, clean seasoning, what happens? There is this particular like this kind of a. If you just consider it to be the ground surface. So this is there, and there are this small, these are just imagine it to be the plank. Okay, and this is the resting place, and above this there are several logs of wood, so they are just stacked above. Okay, so one above the other, and then what happens? Then heat, uh, air, and humidity. So these three things are controlled properly with the help of there are fans. Okay, so there is this fan which blows into this particular stack of wood, and then there are steam pipes also. So this fan and steam pipe together, they are injected in this particular setup in a very controlled manner, and then this wood are basically seasoned. And also sometimes salt or urea, those are also injected into this wood so that it can easily season. So as like chemical seasoning only, we have seen that the salt solution is prepared, and that helps in the easy seasoning of a wood. In kiln seasoning also, this kind of things happen. Okay, Anjali asks which type of chemical. Yeah, urea is used, or salt is used. Okay, any kind of salt can be used for this particular seasoning. Okay. So y'all can you all name any more types of seasoning? Another very famous type of this artificial seasoning is there. Any other names you all can remember? Electric one, yes, right. Electric seasoning is also there. And yeah, right, Harsha. So in electric seasoning, what happens? Electric seasoning, basically, once again, this electricity is passed, and accordingly, this particular this block of woods, they are seasoned. So that is what. And there's this entire setup, okay, of just as you see for the kiln seasoning. Kilns, similarly, this particular thing are there like this. There are this type of chambers are there, so below which electricity passes, so below which there are this electric wires. And at particular, since we know that timber is resistant towards electricity, so what happens, as a matter of fact, this sap gets the moisture basically gets reduces very effectively. So that is also another type of seasoning. It's quite a very rapid kind of a method where the seasoning happens very rapidly. However, it is a bit uneconomical due to the cost and all these things. So maybe not every time this particular kind of seasoning is used. So here basically we sum up like what are the advantages of this timber seasoning. As I was telling it from the beginning of this seasoning thing, it's all about reducing the moisture content, okay, or the sap, which is which is very similar to the average humidity, because we understand that uh, this timber is a organic material, and if we don't reduce the moisture content in it, in due time what will it happen, it will start decaying. And then also, since it's a this particular thing is an organic material, and if the moisture content is not reduced, it will also become a place where the insects and different kinds of fungus and bacteria will infest, okay. Then second thing is that of course it reduces the shrinkage and warping after placement in the structure. So we also understand, suppose just imagine you take the you fell the tree, you take the wood, you cut it into suitable size, and you use for your for any of the purpose. So what will happen, after some time the wood will start losing its moisture, and then what will happen, it will start shrinking. And that's very prominent example of this is during the rainy season. You'll see most of the door, they don't close properly. And so that is one very good example where you find that if the wood is very good seasoned wood, then you will not find any issues regarding this, when particularly if you all are staying in humid areas and all. Otherwise, you'll find that there's this issue when during the rainy season, when the door won't just close, okay. So this is one thing. And then of course it increases the strength, durability and workability as well. And then the tendency to split and decay, that gets reduced. So that is basically repeated over and over again why seasoning of wood is so important. And also it makes it suitable to paint. And of course we know that the particular weight basically reduces when we are seasoning it. So now let's move to our next question. Okay. So this is the seventh question, which says that cracks formed in timber by the rupture of the tissues in a circular direction. So this particular term is important. Circular direction across the annual rings. So these two terms are important, which will help you to understand. Okay, Sumit, Rashmi, all of you are saying, okay, not all, but just two of you. Any more answers? Harsha also says B. Yes, Tubaya waves. I hope I'm pronouncing your name correctly. Okay, this. One of you said radial. Okay, let's see if it's radial or if others are putting it correctly or not. Basically, there's nothing much to say. Yes, it's the cup shake. And shake is a type of defect in this particular wood that happens. Apart from the shakes, we can also find there are other type of defects. For example, we can see knots. We can see there can be other types like ringballs. Are there. So these are very common types of uh, issues or defects in a wood, because we understand that wood is an organic. Now let's see what I mean by this cup shakes and heart shakes, ring shakes. There are different types of the rupture can be in different manner, or the defects can be in a different way. So if you just look into the first image only, so you'll be able to understand that the rupture is happening across the annual rings in a circular direction, so that gives rise to the cup shakes. Okay, then we have heart shakes. So heart shakes, what happens, so from this is the pith, and then surrounding it is the heartwood. So if you see that most of the times in over mature trees, generally what happens, where the width is more at the center, and it generally the width diminishes towards the edge, this type of shakes happen. And from the this particular center, the cracks start developing. So that's what heart shakes are all about. Then there's also star shakes. So star shakes generally happen due to the changes in the temperature, the diurnal temperature, variations. So maybe it can be due to severe frost, or it can be due to more heat, which are confined to the sapwood only. So that as a result of which this particular cracks start developing from outside. So these are some of the key terms that you need to remember, like from which direction, how this things are happening, and why the shakes are why these different kinds of shake you can see in this particular in any timber. So and another is the radial shake. So radial shakes, generally what happens, so these are caused when there is a delay. Just a second, yeah. When there is a delay in sowing after felling. Okay, so after felling, so once you have cut the tree, there are this huge log of wood, but you are uh, delaying the entire processing. So what happens in such a scenario, what happens, this radial shakes, they generally develop in this fine cracks. Okay, they start developing at a distance from the bark towards the center. Once again, the distance, I mean the type of crack starts from the bark, and then it moves towards the center. But yes, there's certain difference between the star shakes and the radial shakes, because in radial shakes you will find that there are widened gaps. Those are starting from the bark, whereas the radial shapes do not generate this widened gaps. Rather, it will just pass through it, and it will just try to develop cracks, which will eventually get widened. Okay, so these are some of the types of defects that we see in timber. Okay, so now let's move towards our next question. Okay, so you have to identify the type of wooden joinery. So there are, so now we are almost, if you can just visualize the course, then you can see that now we are done with all these cutting things, and now we are talking about how we can make things, okay, from the wood that we have got. Now we have already seasoned it, and so we'll move towards the type of joinery, because any material that you see over here, as we have also learned in our course also, you remember that it's not possible to get one huge chunk of wood, and then you get to design your own thing from that particular chunk of wood. It's not possible. We generally get wood in the form of slices, smaller slices, and that needs to be joined in different ways in order to make different kinds of things. So that obviously comes into our construction part. But yes, okay. So Rohit says tongue and groove, Rashmi also says tongue and groove, Sumit is confused about corner but joint probably. Okay, let's see what's the answer. So it's the mortis, yeah, Nagma, right at the absolutely correct. So this is the mortis and tenon joint. I'll also talk about this tongue and groove, and uh, why this particular, tongue and groove, sorry, this yeah, this one is, this one is mortise and tenor. And what is this mortise and tenor, and why you all are confused about tongue and groove also, that also I'll just show you. So in mortise and tenor, there's this particular, this hole which is cut into the timber. If you can see, there's this particular hole. Okay, so here is the particular hole. And then there's this tenon. So what is this tenon? Tenon is basically a projection on the end of a timber for the mortise, for the insertion into a mortise. So this hole or the cutout is the mortise, and then the projected part is the tenon. Now what you have to do, just you have to just take the tenon and put it inside the mortise. So that will help you to form one particular kind of a joinery. And this is often are classified into a type of bearing joint. Why bearing joint? Because bearing joint basically they are, used for this when we have two things to be attached at 90 degree. So that is why, this is known as bearing joint. And also bearing joint gives the strength. So it, if you put it inside, that means what will happen, it is, it is, it's not locked, but it's like it's placed in a manner so that it won't just, move the particular, this the wood which is attached with the help of a tenon will not move from its place. So it is securely placed in with the, with the other side, which is the, which is having the mortise or the, this particular hole. So that is why it's known as a bearing joint. I'll show you with another photo. Just tell me what you feel about that. Now identify this particular type of wooden joinery. Yes, this is tongue and groove. Shubhendu says mortise tongue and, I think is you are there's this particular mistake in typing. But yes, anyways, I understand your answer. Yes, Harsha. So now all of you understand that this is tongue and groove. Now, what's this difference between mortise and tenon and tongue and groove? So let's see. Yes, anybody trying to speak? So here what happens, here also once again you have, this particular one wood which is trying to hold the other, joinery with the help of, which is having this particular kind of a thing. But the basic difference in this two time, in, this both are, locking mechanism, where, this reach projection is there at one end, edge, and then the other is trying to hold it. But the basic difference, if you look into it, is the type of joint that it is, the mortise and tenon is, and the tongue and groove is. So for tongue and groove, it's a widening joint. What does that mean? So previously when I was talking about, mortise and tenon, what did I say? I said that the joint will be, like this, 90 degree. But what happens for tongue and groove, I'll just show you. So if this is one plank of wood from the plan, okay, if you just visualize it from the top, so and you need to put another over here, just beside it. Okay, so this is the other one. So then we use this tongue and groove joint. So it is, the most useful when we, yeah, absolutely correct, Rohit. So it is the most useful kind of, joinery when we are trying to join it along the edge. So it's, yeah, or as you say, along the breadth, or it's along the edge. Okay. So when we are trying to place a number of plank of, a number of planks, just beside one beside another, and we are trying to secure it properly without, we are not just gluing it with some kind of adhesive, because that won't, be durable enough. But we are trying to like widen the entire material that we are using, or as I said, that we don't get the, or we don't always get the, the thing the required size of the plank, so we need to make our own. So for that purpose, for widening purpose, this particular type of wooden joinery, which is known as tongue and groove, is very useful. Okay, so let's come to our, I hope this part is clear to you all. There's this another, this particular question which will once again give you all. Okay, another thing I just missed about this particular tongue and groove joint is that where do we use this kind of joint. It's very very useful when we are doing flooring installations, particularly this kind of this joinery is useful for floating floors. What are these floating floors? Suppose you have a floor slab over here. uh, Pardon my drawing, but yes, if you have a floor slab over here and then you want to put some gap, okay, you just don't want to, like, lay it on just on top of the slab. You have a particular gap, suppose you want to keep it, and then you put the wood. So in that scenario, what happens, this kind of this kind of wooding is or rather, this particular joinery is very useful. And you might ask me, like, why would I suddenly put a gap in between the slab and the final finish of the floor? It often happens if we suppose, if we want to bring some kind of thermal insulation in the on the floor also, or if we want to bring some kind of acoustical sound insulation also, so then also this kind of flooring is used. It's a very widely used kind of a flooring, and you can find enough examples of this particular type. And in this kind of scenarios where floating floors are basically built, there we use this tongue and groove joint. Okay, so this is one very practical example of this particular type of joinery. Okay, let's move to our next question. Let me see if you all can uh, answer this one. So what it says, basically till now, I think you all have understood about widening joint, lengthening joint, bearing joint. Finger joint I have not talked about it. Widening joint I have talked. Bearing joint also we have seen. We haven't seen lengthening joint. Lengthening is basically, if I just explain it in simple words, it's about how your lengthening it. So one was widening it, so width, you're increasing the width, and the lengthening joint is also about how you are elongating it. So even that's also, it can be in different ways actually, lengthening joint. So how you're elongating it. Okay, so I get most of the answers to be B. And finger joint is, there are the smaller groups, multiple groups, where you just put inside the other joint. Okay, I'll just see what's the answer. So answer is P2, Q4, R1 and S3. So yes, it's option B. Okay, absolutely correct to all those who have answered. And now let's just see what tongue and groove. So now you all are quite aware about it. So okay, let me just once again, what's this P2? So P is widening joint, you all know by now, so it's the tongue and groove joint. Then is Q is the lengthening joint. Lengthening joint, type of lengthening joint is table joint. Okay, so the image that we'll see just after it, yes, lap joint is also a lengthening joint. Absolutely correct, Rohit. For example, simple lap, or the butt joint. So those are also lengthening joint, where you see that there's this particular, suppose this kind of wood is there, and it's, so this portion is just put on top of it. Okay, so that's the lap joint. Absolutely correct. Okay, and okay, where was I? Bearing joint. So bearing joint is a dovetail joint, and finger joint is the half blind dovetail joint. Now dovetail joint, you'll find it in different types of joinery, different kinds of joinery. But I'll just explain. I'll give you one small example how these two type of blind dovetail joints are different. So you see here the tongue and groove, the table joint, and next one is the, see over here you see half blind dovetail, and this is just a dovetail joint. Okay, So in dovetail, although the this particular this side is not exactly dovetail, but yes, the upper part is dovetail. But we can always consider it to be the simple dovetail joint. So there's this one particular starking difference about half blind dovetail joint and the other dovetail joint is that if you see from this side, you can see the grooves. Okay, so here you can see the grooves. So even after finish, maybe after polish and all those things, but still you'll be able to differentiate. Even if you look from this side, okay, here also you'll see the grooves are here. You can demarcate the grooves. But if you look into the half blind dovetail joint, which is a type of finger joint, so you'll see that uh, from this side, you can see this is the knob of a particular drawer, and you can see that from this side you won't be just able to figure out that whether the wood is how the or rather how the wood is joined with the other side. So that's the beauty about this half blind dovetail joint, which enables the the carpenter to basically hide the joint from the front end. So if you consider this to be the front end, so you can't able to make it out like what's there on the and or how is it joined. So this particular groovings, the visuals of the groovings can be eliminated. So that is about half blind dovetail joint. Both these dovetail joints are they are used to make drawers or the cabinets and all. So they this dovetail joints are very much useful in making furniture, different kind of furniture, and particularly in making drawers. Okay, just that how you want the finish is all about how you choose the kind of right kind of joinery for it. Okay, so let's move to our next question. Okay, so identify the types of engineered woods. So in our module, we have learned about quite a lot of different types of engineered wood, starting from plywood, batten board. Then we talked about, ma'am talked about particle board, uh, and then the MDF and HDF, medium density fiber board, high density fiber board. So all these things were covered. So all you have to do is that now you have to identify from image A and image B, what are the okay, Rohit says A is fiberboard and B is plywood. Any more? Harsha says A is particle board. Okay, I knew this kind of a small kind of confusion often happens with fiber board and particle board, and that was one of the reason to keep this particular question. B, Harsha says B is veneer. Okay. Okay, more or less I'm getting the answers. Let's see. So A is basically particle board and B is plywood. Yes, Nagma, you're correct. A is particle board and B is plywood. Rashmi also, yes, B is plywood. Harsha, why it's not veneer? It's not veneer because veneers are basically the plywood is made up of a combination of veneers. Okay, so that's what and this one we see it has got a certain thickness, so that is why it's not a veneer. Veneer is basically the thin slice of wood with the help of which this plywood are made. So that is why it's not veneer. Yeah, I mean it's not a single veneer. It's a collective veneer, number of veneers. So it's correct in that way. Okay, so anyways, before moving to the different, also I saw another one telling you said about fiber board. So I'll discuss about that one. And before I go into that, let's just see how this particular particular particle boards are made. So I hope this is more or less clear. When you all get the if you all get access to the PPT, I think there it will be a bit more clearer. So I'll just see how this particular plywood, MDF, and fiber board they are made. So if you look into plywood, what happens is that as I said that there are veneers, and those veneers are laid in alternating directions. What do I mean by alternating? So all type of wood they have a particular direction of grain. Okay, so there's you'll find that there's this particular direction of grain. So if you just put one particular veneer and then on top of it you just put in the other direction. So in this way, if you keep piling it up, so you'll get a plywood. Then there is MDF. So MDF and particle board. MDF is basically medium density fiber board, or you can also find HDF, high density fiber board. So the differences between this MDF and HDF is regarding the density with which the particular fiber board is made. Now particle boards are made with, there are wood chips, there are, this extra things. So wood chips, shavings, fibers, adhesives, all these things are there. So they are just glued together and particle boards are made. Now what is this MDF or HDF, or basically the fiber board? So fiber board is again made of very fine wood fibers only, and they are, glued together and then compressed. So that is the basic difference about particle board and this particle board and MDF or HDF. So fiber boards basically. Okay. So this compression, this compressing it with a certain pressure is the most important thing when it comes to this fiber boards. And if you can see that generally what happens, since plywood is made up of, this alternating layers of this veneers, what happens, as a matter of fact, the rigidity of that particular structure is quite high. Whereas if we look at MDF, it's not that hard as plywood, and for particle boards, it mostly has, it has got low strength. And then when we talk about shape deformity also, due to the, this alternative layers of veneers in case of plywood, generally we don't see much of, expansion or shrinkages. So the shape deformity is also less. Even for MDF also, if the moisture content changes, then what happens, then the shape can change. But if we talk about particle board, and we by now we understand that how particle boards are basically made. So as for that reason, you can understand that, it can expand too much due to moisture, and also how the things are fixed onto the, how they are, what is the holding capacity, nail or screw holding capacity. So for plywood, of course, it's good because once again, that particular pattern, cross grain pattern, which is very important for plywood, is there. Whereas for MDF, since there are fine particles, so if you screw it, generally what happens, screws cannot hold it properly, and there's a lot of dust coming out because it's made of, wooden fine fibers. And for particle board also, it's very similar, and it can, fall apart, because we already understand that it's made of, this particular adhesive, and it's not that strong. So these are some of the differences between this plywood, MDF and particle board. Okay, so now let's move to our last question, which says that, can you identify this particular type of construction? Yes, any answer from your? This particular kind of wall has got a very unique name to it. Rashmi says bamboo and mud. Any more answer? Okay, let's see into just a second. Yeah. Yes. So it's the Bajrik wall or the Bahrik wall. So you'll find this two terms commonly used. So it's all about, how we place the bamboo, and of course the materials, the primary materials, as Rashmi said, it's bamboo and mud. But there's also this particular very fine difference between wattle and daub and the Bahrik or the Bajrik wall. So wattle and daub, if you see, it's mostly what happens. There are these wooden structures, and along with that, there are, these twigs and fine sections of wood are basically, they are attached, and then on top of it, the mud is placed to make a particular, wattle and daub is basically used to build walls. So this is what wattle and daub is all about. Whereas if you look at the Bajrik walls, they also comprise a number of, vertical sections, but they are also held with the help of bamboo sections. So slivers of bamboo, or half cut bamboos, all these things are basically used. And then this particular barrack wall, or basically, or bajrak wall, are basically built. Okay, now bajrak wall can be single bajrak wall. So as you can see here, so just in one side of the this vertical member, you can see this bamboo are basically put, and then on top of it a kind of binding material, for example cement or mud, anything can be put upon it. Or it can be double bajrak wall also, where you can see on both the sides of this particular vertical section, or the vertical member, this bamboo is basically placed. And then you once again you cover it with any kind of binding material or mortar. And this type of this bajrak wall, these are very much resilient to earthquake. And that is why it helps in avoiding the differential stress within the whole wall, which may during earthquake basically, which may just subsequently collapse. In order to avoid that, okay, Rohit says, what can be the expected lifespan of such a wall? See, expected lifespan, this wattle and dog or this bajrak wall, these are very, these are vernacular kind of, construction. And if you look into what is the lifespan, you have to mostly, it's very similar to, if you all just can relate it with the changing of this straw, or the thatched roof. Okay, so it's very similar to that. So you have to maintain it. It takes high, it's highly, it needs to be maintained properly. And mostly it's over the years, each and every 1 or 2 years you have to maintain it properly, because you can understand the kind of materials that are used over here is something which is washable as well if mud is used. And on the other hand, if you use cement mortar, then maybe it can sustain for a longer period. But yes, it depends upon what kind of mortar also you are using. Okay, and generally what happens, this rammed earth walls, or basically rammed earth is used. So for that reason, what happens, this there is a good resistance, earthquake resistance, towards when we are using these reinforcements, bamboo reinforcements. But yes, the problem, as Rohit puts forward, yes, it can be a problem regarding the maintenance if we are using just rammed wall and rammed earth. And so you need to just change it, or just maintain it properly. Okay, so that brings an end to the different questions discussed. Now let me just show you some buildings which I find very interesting, which are made of bamboo. So this one is the first image. This is this is a traditional bamboo house in Assam. And if you look into the feature, this type of structures, you will find it in abundance in the northeast part of our country. And if you all are aware, also this Assam, they are very much prone to flood. So what happens? They build their bamboo houses on top of a stilt, and they have this bamboo ladder, and the entire thing is made of bamboo. This house is made of bamboo, and this is a very common scene if you now go to the northeastern states. Okay, so this is one traditional bamboo house in Assam. So next one, this particular house, if you all can identify, uh, so this is the Asha Niketan by Laurent Fournier. So he is a very well-known architect who is basically working on how to use this bamboo, indigenous materials, bamboo brick and all these things, and not use, I won't say not use, but rather reduce the usage of concrete. So this is one particular thing where you see here how the bamboo has been utilized to make the roof of this particular building called Asha Niketan. And then another example, yeah, I hope it's showing now. So another example is this particular thing. So this is the Bamboo Symphony of Bangalore, which is a example of a very modern building. But at the same time, if you look into this particular exploded image or exploded view of the building structure, you'll be able to understand. Of course, they have used concrete shell roof, but at the same time they are using bamboo fibers and reinforcement. Okay, apart from here, they are using basically bamboo fibers and reinforcement. They are also using, bamboo columns, and apart from that, they are using, this stone for making this retaining wall and all these things. So this is also a very good example. And if you look into the plan of this particular building, the form and plan, you'll see how much of it is, built with respect to the local climate. We often talk about vernacular architecture, right? But even in this modern building, you'll see how each and every the side detailing has been done in such a manner that, it's very much sensitive towards the local climate, local materials, and all these things. Okay, and the last example that I felt like showing you all is, you'll find a number of other examples as well, but yes, these are some of the very well-known structures also. So this is the Bamboo Sports Hall in Thailand by Chiang Mai Life Architects and Construction. So here also you can see it's basically a sports hall. Okay, it's a huge hall where it's entirely made up of bamboo. If you can see the kind of, the joineries, how they are, tied to each other, and this bamboo steps and all this thing, it's a beautiful construction. So this is another example where bamboo is used at abundance. And also when we use bamboo, another thing we need to keep in mind is that uh, where we are getting it locally. So that is also important. So mostly we get bamboo in places where there are, a sufficient amount of rainfall is there. So yes, that is one thing. We can't use bamboo each and everywhere. You can't just go and find a bamboo house in maybe in the western part of our country, just in Rajasthan and all those places. But you'll find it in abundantly in, the eastern and the northeastern, particularly in the northeastern part, because of the climate, because of the entire, availability of bamboo. Okay, so this brings an end to our today's interactive session. Now I would ask, like, if you all have any question. Yes, any question from you all? Thank you, Anjali. Thank you, Rashmi. Apart from that, thank you, Rahul. Apart from that, you all can always, send us any type of questions in the discussion forum, and we are always there. So, Rohit asks, what kind of board is WPC board? It's can you just, I can't recall what do you mean by WPC? Can you just, you know it's of course a type of, engineered uh, wood, but WPC, okay, yeah, it's the wood. I think it's not wood panel, but maybe it's also wood plastic composite board. If I just, I remember. So it's once again, it's a type of, as you said, it's a composite board only. Yeah, yeah, right. It's the plastic wood plastic composite. So what happens is that polymer is used. So it's something around, the percentage of polymer can be something, I don't remember, but maybe 60 to 70% of polymer is used, and then some kind of additive chemical is used, and then wood powder is used. So all these things are mixed together, and then this WPC board are basically, made. And since you can understand that we are using, I mean, when WPC is manufactured, this particular polymer is being used at a higher percentage. You can understand the kind of strength and durability that that particular kind of board will have. So for particle board, we saw that it's just about, the remainings of wood sawings, wood dust, and all these things. Even for MTF also we saw that. However, for this WPC plastic composite, since it's a plastic composite, so it somehow gives more advantage, towards more into the to the, durability side. So that's what WPC is all about. Is this clear? Okay, thank you, Rohit. Okay, so I'll end my session over here. See you all next week. Thanks, Harsha.